Hello everyone, welcome to the Learning Target number 9 video. So obviously I think you all probably knew this was coming because we've done so much work with greatest common factor and least common multiple that now we're going to take the skills that we learned with GCF and LCM and we're going to apply them into the real world, so when you can actually use them or when you would use them. So you know, it's really, if you understand LCM and GCF, it's just taking that and applying it. So I think we'll do fine. I need everybody to please turn to page 20. Page 20 should look something like this. Have two boxes at the top. Okay? Alright, so your target here, as we just went over, I can determine the greatest common factor and the least common multiple in real world situations. Okay? Now I put these two boxes here as just a reminder, just some key words to help you to be able to figure out whether we're doing an LCM or a GCF or an LCM question. Okay? So for greatest common factor, obviously if you use the word greatest, then we're like, if I said what is the greatest amount of this that I could have, okay? That would be a word that you would use for greatest common factor. At most, we could add one here. We'll add maximum. Please add that. All these are words. I could put biggest, highest, I guess. Okay, anything with that extreme, like that's a synonym of greatest. Okay, so all those. The other one I want to pay special attention to is anytime you're taking something and you're breaking it into groups or into pieces. So I want to add pieces on there too. Pieces. So and I'll kind of draw an arrow to this. Like you're breaking it into pieces. So like here in a minute, this question we're going to do, just to go down to it now, that's a piece of rope. And basically, imagine taking scissors and breaking this into equal sized pieces. That would be a GCF question, just because you're figuring out what the greatest amount of pieces you could have. So those are all words that really are going to mean greatest common factor. Okay, so I guess I didn't need to write biggest there, it's right there, but you guys get the point. Okay, least common multiple, obviously least, fewest, smallest, tiniest, lowest, I guess we can add that. We have, what's the other one? Minimum, that's where I was trying to go with that. Minimum. Okay, so we put maximum, there's minimum. So what is the minimum number? That's the same thing as saying what is the least number, the smallest number. And I think that's pretty much good. The one I really want to pay special attention to is the word again. And that's for a special type of LCM question. And we'll get to those. But these boxes are going to be ones that you're going to want to really study. You're going to really want to make sure you know these words, because if you can do these questions and you're able to pick out like the word greatest or the word least or fewest, you'll be able to do them all, because that word is in every question. One of them is. Okay? So let's do number 41 together. Michaela has two types of ropes. She wants to cut the ropes into pieces of the same length for butterfly knots. So basically, she's got this rope here. She wants to take it and cut it like that, like I did earlier. Here we go. Find the greatest possible length that she can cut for each piece so that no rope will be unused. Okay, so she wants both types of ropes to be the same, have the same length pieces cut. Okay. So I guess what I'm saying is you just can't start saying I'm just going to cut it there, cut it wherever. She actually wants them to be a good length. So basically, she wants to know the length has to be a factor of both 84 and 116, because that would mean that that's how many it can be divided. 84 can be divided by that factor evenly, and 116 can be divided by that factor. Okay. Now, I mean, if you think about it, they're both even. She could cut this into two pieces and two pieces, and it would be fine. So just keep that in mind. Okay? So we know that since it says greatest, we go up to our little box up here, we know that that is going to be a GCF question. So here we go. We got 84 inches there. Actually, I'm going to write this over here, more space. And I got 116 there. Okay. Okay, now these numbers are a little larger than what we've been using, but, you know, if you use your strategies, for some of you, you might recognize that you could break this to 7 and 12. That's fine. But let's say you're not, that's a math fact that you struggle with a little bit. What you can do is you can recognize, remember, going back to the beginning, even or odd. And when you recognize that it's even, because it is, you know automatically that 2 is a factor, because 2 is a factor of all even numbers. Okay? So now I've broken that in half. Now remember, if I want to know what this other factor is right there, what I can do is I can actually take 84 and divide it by 2 that way. Okay? And then that'll actually give it to you. Some of you might be able to do it in your head. 42. Okay? Once again, you could say, oh, that's 6 times 7. But if you don't know that, once again, even or odd. It is even, therefore it does have a factor of 2. Okay, this would be 21. Okay, now you're at 21, even or odd. Okay, so it's odd this time. So we're going to check 3, 5, 7, 9. To check 3, we would do 2 plus 1 is 3. Does 3 have a factor of 3? Absolutely. So now we've got to figure out 3 times what is 21? It is 7. Okay, 116, same way. We can do 2 and 58, I believe. Okay, and that is going to be prime. And then once again, that's another even number. So I know it's going to be 2 and 29, I think. Okay, and then that's going to be prime. And then you say, okay, is that even or odd? Well, it's 3, 5, 7, and 9. 2 plus 9 is 11. 11 does not have a factor of 3. 29 does not end in a 5 or a 0. 29 divided by 7 will not give you a whole number. And then remember, the rule for 9 is just the same rule as 3. 2 plus 9 is 11. Is 11 divisible by 9? No, it is not. So that is a prime number. Okay, so now I've got my 2 prime factorizations. So I got 84, and that's going to give me 2 times 2 times 2. Oh, one too many 2s, sorry. Times 3 times 7. Okay, and then for 116, I'm going to get 2 times 2 times 29. And remember, when we're doing greatest common factor, we look for CFs. I see a common 2 and a common 2. So therefore, I use one of each of those. 2 times 2 is 4. And there we go. Make sure that 84 has a factor of 4. It does. 116 also has a factor of 4. So what does that mean? That means that you could cut both of these ropes into 4-inch pieces, and then you wouldn't have like a 3-inch piece or a 5-inch piece. You wouldn't have any wasted of the rope. It would be 4 pieces. Now, if I asked you, if I called this rope A and rope B, and I said, okay, what we're going to do now is we're going to say, we know that we're cutting them into 4-inch sections, but if I want to know how many total pieces, what I'm going to do is I'm going to take 84 and I'm going to divide it by 4, okay, because I'm taking the total length and I'm going to divide it by the amount of each piece, the length of each piece, and then I'm going to divide it. 4 goes into 8 2 times. We subtracting it 0. 4. 4 goes into 4 1 time, and there we go. I know that if this in A, I'm going to have 21 pieces that are 4 inches long. Okay? That's information. And that's the part we're going to get to as we go here. We're going to not only be finding just the GCF or the LCM, but then we're going to have to take the GCF and LCM and apply it. Okay? But you didn't have to on this one, but I just wanted to kind of show you that. Okay, number 42. Giselle buys 2 types of flowers. 48 pink roses and 56 white lilies. She combines the flowers to make identical bouquets, with no flowers left over. Find the greatest number of bouquets that Giselle can make. So there's your keyword again. So right away you know it is a GCF question. So that's one thing I always want to do. I always want you to label what type of problem it is when you figure it out. Okay? All right, so I skipped ahead here just to save a little time. I went ahead and did the trees. Okay, so you could have done that, but I think we're past that. I think we're all pretty good at that. Okay, so I'm going to go ahead and list them out here. 2 times 2 times 2 times 2 times 3. That's 48. And then for 56, we're going to have 2 times 2 times 2 times 7. Okay, again, we're doing GCF, so we look for CFs. I see a common 2, I see a common 2, and I see another common 2. I'm going to use one of each of those and multiply them out. 2 times 2 times 2 is 8. I know that the greatest number of bouquets that Giselle can make would be 8. She can make 8 bouquets. Okay, now, part B. This is what I was talking about, applying it. Okay, this is where probably the hardest part of this whole learning target is. Okay, so basically, we have these 48, and I'm going to put PR for pink roses, and then we have these 56 WL for white lilies. Okay, we know that she's going to make 8 of these arrangements or these bouquets. Okay, so what I like to do is and I know you don't have room for this, so I guess we should maybe do it at the bottom. That'll help you guys. I'm going to just draw 8 circles. Each one of these circles, basically 3, 4, 5, 6, 7, 8, is going to represent one bouquet. Okay? Now, if I know that I have 48 total pink roses, if I want to know how many how many pink roses in each one of these, this is where we use division. So I'm going to take 48 and I'm going to divide it by the amount of groups that I have. And my groups, I mean my bouquets. So I'm going to do 48 and I'm going to divide by 8. Okay, that's going to be 6. So I know that each one of these, and I'll use pink, is going to have 6 of those pink roses. Okay? And if you actually added them up, 6 plus all the 6's added together, or just do 6 times 8, it better give you 48. Okay? Now I'll use green for the white lilies because I can't use white. I know that that's going to be 56 divided by 8. And what's that going to give me? That's going to give me 7. So I know each arrangement is going to have 7 of these white lilies. Okay? So you're going to have to really use division here. Really, really use division. Okay? So that's 6 pink roses and 7 white lilies. Go to the next page. Okay? Alright, a red light flashes every 14 minutes. A blue light flashes every 24 minutes. When will the lights flash together again? There's my key word. If they flash together at 8 a.m. Okay? Now, I'm going to tell you. Oh, you know what? I got to go back here. There's one major word that I want you guys to remember with LCM. Okay? And I want you to write this. This word is future. Okay? Now, the word future itself will not be in the problem. Okay? But when I say future, I'm saying, okay, like a question like this. I know that a red light flashes every 14 minutes. One flashes every 24 minutes. When will they do it at the same time in the future? That's the whole point. So in the future, be used to hearing that, okay? So basically what that means, if you think about it, if a red light flashes every 14 minutes, and say it flashed right now, so I'll use red. So we got it flashed right now. You should be able to tell me in how many minutes will it flash again. It'll be 14 minutes. And then in how many minutes then? 28. From this time I'm talking. So there's going to be 14 minutes between each flash. So I'm just going up I'm doing the multiples of 14. So you see how that works? It's just going up by 14 every time. Okay? Whereas the blue light, it flashes every 24. So that means it flashes right now. Then it's going to flash right here at 24 minutes. Then it's going to flash right here at 48 minutes. And then it's going to flash right here at 72 minutes. And so on. I could go on forever. Hopefully that makes sense. You can see I'm listing out multiples here. So if you got confused, if you did the greatest common factor for 24 and 14, you would get 2. That's the GCF. Okay? Just to show you that answer wouldn't make sense, will the 2 lights flash? Will either of them be flashing at 2 or in 2 minutes? Hopefully you're saying no. They won't both flash at 2 minutes because we learned that if they both flashed right here, then it won't be 14 minutes until the red one flashes. It'll be 24 minutes until the blue one flashes. So there's no way they could both flash at the same time in 2 minutes. Okay? This is why it's an LCM question. So you should start with your prime factorization. Again, I'm going to skip that just to save a little bit of time. I'm going to go straight to the stacking of them. 2 times 2 times 2 times 3. Okay? We know that we have a GCF of 2, which is what I said. Now we're going to take that GCF and we're going to multiply it by anything not used. So times 2, times 2, times 3, times 7. So 2 times 2 is 4, 8, and then 8 times 3 is 24. Then we'd have to go to the side to do 24 times 7. It's going to be 168. So that means in 168 minutes, they'll both flash at the same time in 168 minutes. Now, that is the LCM. It is. No doubt about it. Can't take that away from it. It definitely is the LCM. But the question is not asking for the LCM. It wants to know when. When it says when, it wants to know an actual time when they will flash. So if they flash at 8 a.m., so this right here is 8 a.m. when they flash. Okay? We need to figure out what 168 minutes after 8 a.m. is. So the first thing is to figure out how many hours this is. Okay? Now, we know that there's 60 minutes in an hour, so we know that 120 minutes would be 2 hours. That's 120. So we're going to do 168 minus 120, and we're going to get 48. So that means that's how many minutes are left over after I've taken out the 2 hours. So it's going to be 2 hours and 48 minutes, so that makes it 10:48. Okay? At 10:48, that is when the two lights will actually flash simultaneously, which means at the same time. Which makes sense because look how far they're staggered here. They're not happening. And if I kept going here on this, I could keep going forever and ever, and eventually I would get to the point where I was at 168 here, and I was at 168 here, and they were happening at the same time. Okay? All right. All right. Number 2 here. Let's go ahead and read it together. The line A bus arrives at the bus stop every 25 minutes. The line B bus arrives every 15 minutes. They are both at the bus stop right now. In how many minutes will they both be at the bus stop again? So again, we're always trying to look for these key words, and I see one right there. Again, if we flash back here, you see again right there. So that's definitely one that we can really key on to know that we're talking about LCM. But remember, I had you write this one real big on the front. We're trying to figure out when two things are going to happen at the same time in the future. This is always going to be an LCM type of question. Okay? So if this was the bus stop right here, we got bus stop and bus stop. Right now, because it says they are both at the bus stop right now. So here's A and here's B. Okay, so you got to remember A is going to be back every, so this is a bus stop again. So this will be in 25 minutes. Whereas bus stop B is going to be in 15 minutes. So if we kept going here, if we went another 25 minutes, then that would be, from right now, that's going to be 50 minutes. So it's just the multiples. So we got, and I know I'm writing somewhere where you already have writing, so just do your best to fit it in somewhere. But, you know, it's just basically writing out the multiples. So if we were just listing out all the multiples of 25, that would give us the, you know, when that bus A is going to be there. From right now, if right now the bus is at the stop, that's a stop sign, by the way. It's at the stop sign. I know that from 25 minutes from right now, it'll be back. 50 minutes from right now, it'll be back. 75 minutes from right now, it'll be back. 100 minutes from right now, blah, blah, blah. Okay, it goes on and on. Whereas the other one is every 15. So it's coming and going a little more frequently. So we got 15. From right now, it'll be back in 15. It'll be back in 30. It'll be back in 45, and so on. You're just adding 15 every time. But obviously, you need to show the work. So I would need to see the trees. We've identified that it's happening in the future, that it's LCM. We got 5 and 3, and we got 5 and 5. Okay, now remember, the first step to doing least common multiple is to find the, hopefully you're all saying G, C, and F. GCF. So we're going to find the GCF, so we're going to stack those prime factorizations, 3 times 5, 5 times 5. We look for CFs. I see that they have a common 5, and I know my GCF equals 5. Now remember, that's not the answer. That is just going to help us get the LCM. Obviously, some of you stop right here and say, yep, that's my answer. Ask yourself if it makes sense. Or is either one of these buses, if they're right there right now, are either of them going to be back at the bus stop in 5 minutes? No, they're not. That's what I want you guys to start thinking about, really thinking about the answer, if it even makes sense. Okay? Absolutely not. So then we got to take that GCF and we need to multiply it by anything that wasn't common. So times 3 times 5, and I'm going to do 5 times 5, or 5 times 3 is 15, times 5 would be 75. So right now I'm thinking, okay, so every 75 minutes, so if I kept going here, every 75 minutes, I know that they're both going to be at the bus stop. So if I kept going here, I could then list out all the times. 75 minutes from right now, they'll both be there. 150 minutes, they'll both be at the stop. 225 minutes, they'll both be at the stop. 300, they'll both be at the bus stop. All I'm doing is adding 75 each time. Okay? Next one. Read through it real quickly here. Joanne, or Joan, I'm not sure which, Joan, I'm going to go with, is campaigning for class president and plans to distribute some campaign materials. She wants to distribute 20 flyers, underline that, and 16 buttons. She wants each classroom to receive an identical set of campaign materials without having any materials left over. What is the greatest number of classrooms Joan can distribute the materials to? So, because of all those words, we know that this is a greatest common factor type of question. So I'm going to start by doing the prime factorization here. That's 4 and 5, which would break to 2 and 2. And then 16, 4 and 4, which breaks to 2 and 2. Okay? Then we stack those up. 2 times 2 times 5, and 2 times 2 times 2 times 2. I look for CFs. I see they have common 2's and common 2's. I know that's going to be 2 times 2, which equals 4. I know that the maximum, whoa, that's not going to work. I know that the maximum number of classrooms she can distribute to would be 4. Okay? That is the answer. 4 classrooms. All right, let's go on to the next one. Go ahead and just cross off number 5 for now. We're not even going to bother with it. Okay? Okay. Now, it takes 20 minutes for Mr. Edwards to finish a crossword puzzle. Mrs. Allen takes 8 minutes to finish a puzzle. If Mr. Edwards and Mrs. Allen start doing puzzles right now, how long will it be? How long will they be doing puzzles before they can complete one at the same time? So, basically, because this is future, again, we're trying to figure out when these things are going to happen at the same time in the future. We know we're talking about an LCM question. By the way, same time again, if you go back to your little box here, oops, right here, we know that was, remember, same time. I think I wrote it in there somewhere. But regardless, if I didn't, let's write it now. Same time, that's usually a pretty good indication of LCM. So we're going to find the LCM of that. So we're going to find the LCM of 20 and 8. So we're going to start with the prime factorization. Break it to 2 and 10 or 4 and 5, doesn't matter. For 8, 2 and 4, 2 and 2. So that's going to be 2 times 2 times 5 and 2 times 2 times 2. Okay. Remember, the first step to doing LCM is to find the GCF. That's step number 1, so we look for CFs. I see a CF of 2 and a CF of 2. Therefore, my greatest common factor is 4. Okay? Now, we got to take that greatest common factor and multiply it by whatever wasn't used. So there we go. 4 times 5 is 20. Times 2 would be 40. So that means 40 minutes into them starting to finish puzzles, they are both going to finish a puzzle at the same time. So 4 times 5 is 20, times 2, then would give us 40. Now, what does that mean? That means that at 40 minutes, so if they started doing puzzles right now, when they both are at 40 minutes from when they started, they will both actually complete a puzzle at the exact same time. That's what we're trying to figure out. So that is the LCM, 40. Okay? Now, if we need to figure out, this is where these can get kind of tricky. How many puzzles did Mr. Edwards complete? Well, if he's completing them every 20 minutes and 40 minutes has gone by, I think that's pretty easy math to say he would have completed 2 puzzles. Okay? How many total puzzles will Mrs. Allen have completed? Maybe a little bit harder. But what you're doing is if you take the LCM and just divide by however many, like for instance Mr. Edwards, he does one every 20 minutes, 40 divided by 20, that's how I got 2 puzzles. Okay? And then 40 divided by 8 minutes, because she does one every 8 minutes, would show us that she's going to be able to get 5 puzzles done. Okay? Okay, thank you.